Hi everyone, it's Miss Campbell. I miss you all a lot and I hope you're doing well, and I'm excited to do today's lesson, which is 8-1. So 8-1 is on multiplying and dividing rational expressions. And so we know that a rational expression just means that there is a polynomial in the numerator and denominator of a fraction. So first I'm going to go over multiplying rational expressions. So for all rational expressions, a over b and c over d, a over b times c over d equals ac over bd if b does not equal 0 and d does not equal 0. So this is because we can never have 0 in our denominators, right? So now I'm going to go over an example. So say we had these two rational expressions. The first thing we're going to do is simplify. So to simplify, we're going to look for the greatest common factor of the numerator and denominator. So this may involve a more complex factoring method, like using product sum, or we could just take out the greatest common factor. So like in this case, with this first rational expression, our denominator is m squared minus 6m plus 9. So then we can use the product sum method and factor and get m minus 3 squared. And then with the second rational expression, we can just take an m out of the top because that's our greatest common factor. So when we take an m out, we're left with m times m squared minus 9. So that is as much as we can factor it. So now all we're going to do is just cancel out what we can and see what we're left with. So on the left, we have m minus 3 squared over m minus 3 squared. So obviously anything divided by itself is going to equal 1. So we can just cross both of these off. And then on our right side, we have m times m squared minus 9 over m squared minus 9. And so once again, we have an m squared minus 9 in the top and an m squared minus 9 in the bottom. So we can cancel those off. And then we're just left with 1 times m, which equals m. So now we need to look for restrictions on our denominators. So basically, we need to set the denominators equal to 0 to see what values of m cannot exist. So I'm going to set m minus 3 squared equal to 0 because that is the factored form of m squared minus 6m plus 9. And when I do that, I get that m cannot equal 3. And then I'm going to set m squared minus 9 equal to 0. And then, so to do that, I'm going to first have to factor. So factoring using the difference of squares method, I get that m squared minus 9 is equal to m plus 3 times m minus 3. So then setting those two equal to 0, we get that m cannot equal negative 3 and m cannot equal 3. So our final answer is m, but m cannot equal negative 3 or 3. So now we're going to learn about dividing rational expressions. So for all rational expressions, a over b and c over d, a over b divided by c over d is going to be equal to ad over bc if b does not equal 0, c does not equal 0, and d does not equal 0. And the reason for that is when we have two fractions and we're dividing them, that second fraction, we're going to flip it, right? But then when we flip it, we now have a new polynomial, in this case, in our denominator. So then, therefore, c is also not going to be able to equal 0, in addition to d and b, which are originally in the denominator. All right, so let's do an example. So say we had these two rational expressions and we're dividing them by each other. The first thing we're going to do is simplify. So I'm going to simplify 16p squared minus 8p plus 1 just by factoring. So when I factor, I use the product sum method and I get 4p minus 1 squared. And then we can't do anything else with that side. So then on the right side, we have 4p squared plus 7p minus 2, which we can factor into 4p minus 1 times p plus 2, and then that's going to be over 7p to the 5th, which we also can't do anything else with. So then now we're going to flip it and multiply. So we now have 7p to the 5th on the top, and we have some stuff that we can cancel out. So now we have a 4p minus 1 squared on the top, and a 4p minus 1 on the bottom. So that means we can cancel 1 out from the bottom, and then we're just left with one of those on the top. And then we can also divide the numerator and denominator by 7p to the 4th, and then we're left with just 2 in the denominator and p in the numerator. So then when we multiply those two simplified rational expressions together, we get p times 4p minus 1 all over 2 times p plus 2. So then now we're also going to look at what values of p can exist as a result of them being in the denominator. So we're going to set 14p to the fourth equal to 0, and we'll find that p cannot equal 0. We'll do the same with 7p to the fifth. That also can't equal 0, so p, once again, cannot equal 0. And then we're going to take what's in the denominator here and set that equal to 0 as well. So we'll have two separate factors that we'll set equal to 0. So we have 4p minus 1 cannot equal 0, so therefore p cannot equal 1/4, and then p plus 2 cannot equal 0, so p cannot equal -2. So then the restrictions we have are p cannot equal 0, 1/4, or -2. Okay, so I'm going to do a couple more examples. So this one just has a lot of different variables multiplied together, which might look a little intimidating. So another way we might see this is in this form, which we can just take and rewrite into this form here, which makes it a little easier to understand how we need to multiply by the reciprocal. So we're going to multiply by the reciprocal, so the ab squared goes in the denominator, and the c to the fourth x squared y goes in the numerator. So now I'm just going to cancel out the things that I can. So I have 1b in the numerator, and I have b squared in the denominator, so therefore I'm going to cancel out a b from the denominator, and then we won't have any b's left in the numerator. So then I'm also going to look at the a variables. So I have an a squared in the numerator and an a in the denominator, so that means I can take 1a out of the denominator and be left with just 1a in the numerator. And then I'm going to also look at my x variable. So I have an x squared in the denominator and an x squared in the numerator, so those are just going to cancel out perfectly. And then I have a y in the numerator and a y squared in the denominator, so we're left with just 1y in the denominator. And then the c's aren't going to cancel out. The c's, we're just going to add their exponents, right? So we're left with a c to the seventh divided by by. So now a, b, c, x, and y are all not able to equal 0 because we're going to set each denominator equal to 0 and also this numerator ab squared equal to 0, because when we flip and multiply, that becomes the denominator. Okay, so one more example. So say we had these two rational expressions divided by each other. So we can either simplify first by factoring, or we can do the flipping and multiplying first. I, for some reason, decided to do that first in this case. So I flipped it and changed the division sign to multiplication, and now I'm going to factor so that I can eliminate some stuff. So factoring x squared plus 19x plus 84, I get x plus 12 times x plus 7, and then in the denominator here, I'm just going to take out a 2 because when I do that, I'm left with the same polynomial here as I am here, and I know that's going to be able to cancel out. And then in the denominator on the right, I'm also going to factor x squared plus 9x plus 14, and when I do that, I get x plus 7 times x plus 2. So now I'm going to cancel out everything I can. So I can cancel out the x plus 7s, because we have one in the numerator and the denominator. I can cancel out the 2x minus 2 and the 2x minus 2, and that's about it. So I'm left with x plus 12 all over 2 times x plus 2. So now I'm going to set the denominator equal to 0 here, the denominator equal to 0 here, and also the numerator equal to 0 here. And I get that x cannot equal 1, x cannot equal -2, and x cannot equal -7.